So again, we're going to talk about negative and zero exponents. I'm going to write some powers up here with their value, what the value equals, and I want to see if you can find the pattern here, okay? So we know that 2 to the third power means 2 times 2 times 2, which is 8. 2 to the second power equals 4. 2 to the first power equals 2. So then, if you notice, my exponents keep going down. 3, 2, 1. So I'm going to say 2 to the 0 power, what would that equal? 2 to the negative 1, 2 to the negative 2, 2 to the negative 3. Okay? So looking for a pattern here over in our values, that right-hand column. So again, you can see the pattern that I have in my left-hand column of my exponent reducing by 1 each time. What is happening in the right-hand column? It's dividing by 2 each time. We're taking half each time. Okay? 8 divided by 2 is 4. 4 divided by 2 is 2. So if we wanted to say what is 2 to the 0 power, we would do 2 divided by 2, which is 1, yes. And then if we wanted to say what is 2 to the negative first power, we would do 1 divided by 2. What's that? All right, I'm going to write that as a fraction, so 1/2. And then if I did 1/2 divided by 2, 1/4. And if I did 1/4 divided by 2, 1/8. Now, look at the pattern there. What do you notice about the numbers 8, 4, 2, 1, 1/2, 1/4, 1/8? What do you see there, Damon? Good. So the denominators down here, this 2 is the same as this whole number 2 up here. And this 4 as a denominator is the same as this whole number 4 up here. Same thing for the 8. So we can imagine if we had 2 to the 4th power, which would be 16, then 2 to the negative 4th power would be 1/16, right? All right, and that kind of leads us into what our rules are here. So first of all, let's talk about the 0, when the exponent is a 0. That's probably the easiest rule, okay? Sorry. All right, so our first rule that we're going to write down is about when your exponent is a 0. If a power has a 0 for the exponent, if a power has a 0 for the exponent, the power equals 1. If a power has a 0 for the exponent, the power equals 1. It does not matter what the base is, okay? So the base could be a number. For instance, 8 to the 0 power, that's going to equal 1. Or maybe the base is an exponent. Maybe you have w to the 0 power. It would also equal 1. So it does not matter what the base is, how big or how small, or if it's a variable or a number. If the exponent is a 0, then the entire power equals 1. Well then, so our other rule was when we have a negative exponent, if a power has a negative exponent, so again, if a power has a negative exponent, what we're going to do is we are going to move the power to the denominator and change the exponent to a positive. Move the power to the denominator and make the exponent positive. If a power has a negative exponent, move the power to the denominator and make the exponent positive. I'm going to give you a second to write that down, and then we'll do examples of that. Let's show some examples. For instance, let's say I have 7 to the negative 5th power. And if I want to write this power so that it doesn't have a negative exponent, I would just take this entire thing and I would move it down to the denominator, and instead of a negative 5, I'm going to make it a positive 5, and then a 1 is going to be in the numerator position. Okay, so a lot of times it'll ask you to write your answer with only positive exponents, so this is what you would need to do in that situation. It works the same way when your base is a variable. If we had m to the negative 11th power, m to the negative 11th power, again, if we move that power down to the bottom, it's going to become a positive 11. Any questions about that? Alright, so basically what we're going to be doing now is some examples where we're using those rules. Okay, and you'll always want to read the directions carefully. Sometimes they say that they want you to write your answer with only positive exponents, and other times they'll say that they want you to write your answer with no fraction bars. So that means that there's going to be negative exponents. Okay? So the first ones that we're going to do, we are going to make sure that we rewrite the expression using only positive exponents. Rewrite the expression with only positive exponents. So I'm going to give you some to do. I think hopefully after the examples that we had, that you'll be okay. For instance, we'll start off easy. If I just had 3 to the negative 5th power, why don't you write in your notes what you think it would be? What'd you get? 1 over 3 to the 5th power. You do not need to actually work out 3 times 3 times 3 times 3 times 3. Okay, you do not need to do that. So you would just leave it like that. Alright, a little bit more difficult then. What if I had m to the 0 power and n to the negative 4th power? Now when we have an expression like this that has more than one variable, we need to think of each of these powers individually. So for instance, I'm looking at just the m to the 0 power and thinking about what I'm going to do with that, and then looking at the n to the negative 4th power and what I'm going to do with that. Okay? So m to the 0 power, what does that equal? 1. So this whole thing equals 1, which kind of means it just goes away. Alright? 1 times anything, that 1 is, that 1 doesn't show up. Okay? So now, what am I going to do with n to the negative 4th power? Good. We're going to move it down to the denominator, so it's going to be 1 over n to the 4th power. So notice your m doesn't show up anymore. M to the 0 power, it equals 1, so it is gone. Alright, let's do another one. Let's say we have 16 x to the negative 6th power y. So in this one here, I basically have 3 things I need to look at individually. The 16, the x to the negative 6th, and the y. So 16. What is the exponent that this 16 really has? A 1. Is it fine then? Is it positive? Is it a positive 1? Yes. So that means that my 16, when I have my fraction, my 16 gets to stay in my numerator. I don't want to move my 16 down because it has a positive 1 for an exponent. What about this x to the negative 6th power? What do I do with it? Move it down. Good. So when I move my x down, my 6 becomes positive. And then what do I do with my y? Put it on top. So that y has an exponent of a positive 1 also, and it would stay on top. So your final answer would be 16y over x to the 6th power. Pretty easy? Alright, why don't you try one, and then we'll move on to something a little bit different. So 12a to the negative 7th power, b to the 3rd power. You do that one. Alright, Tommy, what'd you get? That's good. So the 12 stays on top. Your b to the 3rd power stays on top. Both of those had positive exponents to start with. The only thing that we want to move to the bottom would be our a, and that's negative 7 is going to become a positive 7. So that would be your final answer. All right, any questions about this skill? All right, then the next thing that we're going to do is kind of the opposite. I'm going to give you something that's in fraction form, and we are going to rewrite it so that it doesn't have a fraction bar, okay? So we are going to rewrite the expression without a fraction bar. For instance, if I had a to the second power over c to the third power. So we're doing the opposite of what we just did. So that means anything in the denominator, I want to move up to the numerator. Now what's going to happen to my exponent of 3 when I move it up? It's going to become a negative, exactly. So this is going to be, my a would stay a squared, that doesn't change, but my c to the third is going to become c to the negative third, and that would be your answer. Okay, so again, anytime you move the position from either top to bottom or bottom to top, you take the opposite of your exponent. What if you have 9w to the 6th power over x to the 4th y to the 2nd? We have more that we'll do today. We're going to combine what we did yesterday with what we've learned today. So, all right, Daphne. Nine w to the 6th, x to the negative 4th, y to the negative 2nd. There we go. Also, just to point this out, normally you always want to make sure that your number is listed first. Your coefficient's always out in front of your letters. And then your letters should always be in alphabetical order. Okay, letters go in alphabetical order. So W, X, Y. I'm sorry, what was your question? You sure? All right, so one more of this type that I want you to look at. If we had something like 1 over 16, I don't want you to just write this as 16 to the negative 1st power. What you want to do on this one is you want to do the prime factorization of 16. Prime factorization of 16. Now, we've practiced prime factorization recently. So what could we do for prime factorization? Factor tree. All right, 4 times 4. Each of those would be 2 times 2, right? So what is the prime factorization of 16? 2 to the 4th power. 1, 2, 3, 4. So this equals 1 over, 2 to the 4th power. 16 is 2 to the 4th power. Now that is what I want to rewrite without a fraction bar. So what is 1 over 2 to the 4th power? 2 to the negative 4th power. So again, if you have something that's just like 1 over 16, you want to do prime factorization and then make it so that your prime factorization is moved up to the numerator and you change those to negative. Okay, let's combine what we did yesterday with what we are learning now. Okay, I want to rewrite these with no negatives. So no negative exponents in the final answer. Okay, final answer, no negative exponents. Starting off easy, won't get harder. 5 to the 10th power times 5 to the negative 6th power. So you may have hoped that adding and subtracting integers has gone away, but unfortunately it has not. So this follows the rules that we did yesterday, which is keep your base and add your exponents. So what is 10 plus a negative 6? 4. You will be able to use calculators, but I really hope that you can do these without calculators. Now, since that's a positive 4, we can just leave it as is. We don't have to do anything else with that. What if you have 3 to the 7th times 3 to the negative 11th power? So we're going to do 3, 7 plus a negative 11. 7 plus a negative 11 is negative 4. And I want to rewrite it so I don't have a negative exponent. So it's going to be 1 over 3 to the 4th power. We okay with that? So again, same rules that we had yesterday. All right, let's do some of those quotient of power rules that we had yesterday. Remember when it is a division problem that you're going to be subtracting your exponents, which actually makes it a little bit harder here. Let's say we have n to the negative 3rd power over n to the 2nd power. Now, I highly recommend, because these kind of get a little confusing if you just try to do it all mentally, I highly recommend that you write down what you're doing here, okay? You're doing negative 3 minus your 2, which is negative 5. Negative 3 minus 2 is negative 5, and then we rewrite that. Once you know what to rewrite, then that's like the easy step. What's going to happen, though, if we have something like w to the negative 5th over w to the negative 8th? So this is what I was talking about with making sure that you kind of write it down and don't just try to do it in your head. So w, negative 5 minus negative 8. Remember, you're subtracting your exponents. So negative 5 minus a negative 8 would be written like that. So that really means negative 5 plus 8, doesn't it? Two negatives right by each other make a positive. So it would be 3. So these can get complicated. Again, my advice to you is to write it out so that you don't get mixed up on these positive, negative things. All right? All right, let's do one last one, and then I think we will be good. So in this last one that I'm going to do, I'm going to put some coefficients in here. Let's say that I have 21g squared over 14g to the negative 4th. Now let's not worry about our g's for a while. Let's think first about our 21 and our 14. What are we going to do with our 21 and our 14? Simplify. So 21 and 14 can both be divided by 7. 21 divided by 7 is 3. 14 divided by 7, 2. All right. Now let's think about our g's. So g, 2 minus negative 4 becomes 2 plus 4, which is then 6. Where am I putting that? On top. Now, if I would have ended up with g to the negative 6, then technically g to the negative 6 is on top, but I don't want it negative 6, so then I could move it to the bottom to make it positive. Make sense? Ready to try it on your own? Okay.